All right, so Chapter 10, Section 1. We're going to leave this first page blank. We'll fill it in when we review for Chapter 10, or kind of as we go along and get different vocabulary parts. My suggestion would be that you go through the first page of this section on your own, and then you use the first part of the video just to check your answers and make sure you have all of the information correct, and then go through the second page with me step by step. The first part says scan the text under the Now heading. List 2 things you will learn about in this lesson. So under the Now heading, it says how to identify parts of the circle and how to find the circumference of a circle. So I put those 2 things down. All of this vocabulary is specifically from Section 1. There's 11 words, so there's a lot of vocab. Some of this will be review, but it's all an important part of Chapter 10, so make sure you understand the definitions before we move on. So the first one says, what is the distance around the circle? We call that not the perimeter, but the circumference. And we will have an equation for that on the next page. A segment with endpoints at the center and on the circle is called the radius. So if I were to draw this out, and I have my circle here, the radius has an endpoint on the center and on the side of the circle. So we know that there are 2 radii for every 1 diameter, but the specific definition of a radius is a segment with endpoints at the center and on the circle. The locus, or set of all points in a plane that are equal distant from a given point, is actually the definition of a circle. That given point is the center, and all of the points that are the exact same distance from that center make up the circle. 2, coplanar. We had coplanar back in Chapter 1. Co means together, planar means plane, so they're going to be together on the same plane. 2 coplanar circles that have the same center are called concentric circles. So think of this as like a dartboard. Circle with a center, and this circle has the same center. They're concentric circles. A chord, which passes through the center of a circle and is made up of collinear, co meaning together, linear meaning line, so together on the same line, would be called a diameter. So if I have a circle with a center, and I have 1 radii and another one on the same line, makes up the diameter. So the diameter goes through the center, and it goes from one side of the circle to the other. An irrational number, which by definition is the ratio of the circumference of a circle to the diameter of a circle, is pi. So when we say ratio, that means we can write it as a fraction. So pi, is literally the fraction of the circumference over the diameter. So if you take the circumference of a circle and you divide it by its diameter, you will get pi every time. The descriptor given to a polygon which is drawn inside, keyword there would be inside, a circle such that all of the vertices lie on a circle, we would say that figure is inscribed because it is inside. The name used to describe the given point in the definition of a circle, well, we said that up above here, the given point is the center. You will always name the circle for its center. So if I have a circle whose center is P, this would be circle P. It's always named for its center. A segment with endpoints on the circle is a chord. Notice the difference in the definition between a chord and diameter. A diameter is a chord that specifically goes through the center. A chord is any segment that has endpoints on the edges of the circle. So a chord does not have to go through the center, whereas the diameter does. So every chord is not a diameter, but a diameter is a chord. The descriptor given to a circle which is drawn about the polygon, such that the circle contains all of those vertices, is circumscribed. So inscribed describes the polygon that's inside. Circumscribed describes the circle that's drawn about that polygon. And the last one, two circles with congruent radii are called congruent circles. If they have the same size radius, they will be the same size circle. Okay, so let's move on to some examples and some formulas. So, compare and contrast the pairs of special segments of a circle drawn in the diagram below. How are a radius and a chord related? Well, first of all, we said a radius goes from the center of the circle to the edge, and a chord goes from one side of the circle to the other. So they're not related, other than the fact that they both have at least one endpoint on the circle. So I could say something like a radius is not a chord because it only has one endpoint on a circle. Okay, what about a chord and a diameter? Well, we said a diameter is a chord, but it goes through the center. So I could say just that. A diameter is a chord that goes through the center. Okay, and the last one is relating the radius and the diameter. Well, let's write these out as formulas. If I call the radius r and the diameter d, the diameter is double the radius because it's made up of two collinear radii, which means the radius is half of the diameter. So I can switch between the two using either of those formulas. So that brings us to circumference. Circumference is pi times the diameter, which means based off of this, I could also rewrite the formula as 2 pi times the radius, because I know that the diameter is made up of two of the radii. So this problem says the circumference of a circle is 234 inches. Determine the radius and the diameter of the circle to the nearest hundredth of an inch. Start with c equals pi times diameter and fill in what you know. Well, we know that 234 is the circumference, so I'll fill that in where I see c. Now I'm going to solve for the unknown. In this case, I'm going to solve for the diameter first. So I will divide both sides by pi to get d by itself, to find that d is, to the nearest hundredth of an inch, 74.48. Now I have to figure out the radius. Well, again, based off of this, the radius is half of the diameter. So I'm going to take the diameter and divide it by 2. So now I have both the radius and the diameter. Look up the origins of the two parts of the words diameter in your dictionary. Explain the meaning of each part and give a term you already know that shares the origin of the part. So let's look at dia. It's split into two pieces. Dia literally means across or through. think of diagonal. The second part of the word comes from the word metron, which literally means measure. So the diameter literally means the measure across or through the circle. Makes sense. All right, so that's the end of section 1. You'll work on section 1